prior, which is invariant to reparameterization. So it means if one thing is a function of another, you can actually map it all the way through and it doesn't change. And then we should know what the functional form of Jeffrey's prior is. It's the square root of the information function, which in general is I of theta. You replace theta by your specific parameter that you're interested in, which is the square root of the expected value, so it's minus the expected value of the second derivative with respect to whatever parameter you're interested in of log of the likelihood. So yes, it is a bit of a monster. However, you just break it down. So here, we're going to be looking at f of y given mu is equal to, and that's technically yn, mu to the sum of yi e to the minus n mu times the product I equals 1 to n of 1 over yi factorial. You'll see the main reason for taking logs becomes very obvious now. Because do you want to be differentiating having to deal with this? No. Taking logs means we don't have to. Yay. Seriously, if you have a difficult differentiation to do, just log it. It often makes it a whole lot simpler, and you get the same. If you're looking for maxima or minima, you get the exact same values. So it's equal to the sum yi times log of mu minus n mu plus what's technically becomes a minus because this is to the power of minus 1 log, and the sum becomes a product 1 to n yi factorial. Essentially, all this though becomes irrelevant because there's no mu in it. When we differentiate the first time, log of f of y and mu d mu equals d mu of the sum of yi log mu minus d mu n mu. The rest is plus 0, which is the sum of yi 1 over mu minus n. And then we get the second differential. D squared log of f of yn given mu d mu squared is equal to d mu, the sum of yi 1 to n of mu to the minus 1 plus 0 because that has no mu minus 1, so minus the sum of y equals 1 to n and over mu squared. Okay, so we've made quite a bit of progress. Now we have to get the expected value of that with respect to mu. So we have the expected value of all of this, of f of yn mu d mu squared. We're given mu, so that's going to be minus, what's the expected value of this? It's going to be n mu over mu squared equals minus n over mu. And then you're asked to find the square root, I'm going to do this in 2 stages, of minus the expected value of the second differential of the log of the likelihood given mu is equal to the square root of n over mu. And you only care about this up to proportionality. N is a constant, so that's proportional to the square root of 1 over mu, which is equal to 1 over the square root of mu. And you are only ever concerned about Jeffrey's prior up to a constant of proportionality.